Let's start it. All right. Good morning, everyone. My name is Kijin Song, and I'm a postdoc researcher in the Urban Information Lab in the School of Architecture at UT Austin. Welcome to our lightning talk series on smart city research. This talk series is funded through the UT's Good System project. So we invite the speakers from academia, industry, and the communities to share the research events and the needs related to the smart cities. So if you are interested in this topic, please feel free to visit our website to our past talk and other activities at smartcity.tech.utexas.edu. So today, we are very excited to have Mr. Brett Barganz as our guest speaker. Brett is a senior principal at Verizon, focusing on network as a service for public sector. He has expertise to lead organizations through their visions of change, especially technology, transportation. Brad can offer insights into every part of their journey, from envisioning a solution to implementing and operating it, with a deep understanding of public sector and its systems from years working and consulting for local and state government. Before joining Verizon, Brad served 10 years in municipal and county administration roles, including the manager's office, public work, police, fire, and enterprise technology. He also served 5 years in advisory roles, providing project management, organization change management, and IT guidance for public sector enterprise projects. Finally, for Verizon, Brad has served 2 years providing strategy management and consultative solution support for advanced technologies and networking products for public sectors. So today, he will talk about 5G, the future of public sector technology. So without further ado, I'll pass the mic to Brad.
Thanks, Kijin. Can you hear me, see me?
Yes, we can see you and hear you.
Awesome. And just to confirm one more time, I think you're seeing a cover slide that says 5G, the future of public sector technology. Is that right?
Yes.
Awesome. Okay. Well, I appreciate everyone having me today. That was a very kind introduction. I appreciate that. And I, as mentioned, would like to speak to you a little bit about how we see 5G playing into the future of smart cities and their evolution, and specifically how those relate to how first responders and frontline workers for public sector will do their jobs going forward. I am happy to take questions throughout, Kijin, if we want to take them. Otherwise, I'm happy to present and take questions after, or even folks can reach out to me separately if they'd like to do questions after the session. Okay?
Sure. Thank you.
Sure. The stuff we'll talk about today is proprietary to Verizon. The recording and presentation can be shared, but just know that they're proprietary to us and should be not used again for commercial purposes. All right. So before we get into use cases to enable smart cities in the future for public sector, I want to talk a little bit about what 5G is, just make sure everyone has the same foundation, right? A lot of people have at least tangentially familiar with 5G, but I want to make sure everybody has a good solid foundation for the conversation. So 5G is the next evolution. I will actually call it a revolution in network technology, but the next evolution in network technology, and it actually takes place over a pretty wide range of spectrum, from low band up to high band. Previous generations utilized an even lower band than what you're seeing here, sub 1 gigahertz. And what's really interesting about the different spectrums is that as you get higher, you have more capacity to carry traffic, right? So high band has very high throughput, but the downside to that is it does not travel as far, right? So high band can't go as far and does get blocked more easily by things like buildings, trees, even raindrops in some cases. Low band is the opposite of that, right? Lower throughput, but also has the ability to travel much further and has a greater ability to go through objects. So both are a necessary component of providing our next generation network, and Verizon uses low band, mid band, and high band to do this. So terms that we might use going forward to refer to these are 5G nationwide. That's what Verizon offers in terms of low band. So throughout the entire nation today, we have what's called 5G nationwide, which is our low band 5G. Again, lower throughput, but higher ability to penetrate. What we are still rolling out today, and what we recently just covered 200 million customers with total, is 5G ultra wideband. So that's using our mid band, often referred to as C band, and our millimeter wave bands, or high bands, to cover, starting with large urban centers, but then expanding out through the country, additional populations with much higher throughput 5G. And when I say evolution versus revolution, the nationwide is definitely an evolution. It's a step up from the previous generation 4G or long-term evolution, but it's not revolutionary. Wideband is revolutionary, right? That's going from probably an average of 50 megabits per second download to 1, 2, or 3 gigabits per second of download, right? A massive increase of downloadability. And also, it's not just throughput that is this revolution that is ultra wideband, but also the ability to put a huge number of Internet of Things devices for smart cities, for example, on our network. It's going to allow potentially up to 1 million devices per square mile, which is a vastly larger number than the previous generations could handle. And that's where it is more revolutionary rather than evolutionary. And finally, one thing we'll talk about is what's called edge. And this is a word that's thrown around a lot, so I want to make sure I define it well. So on top of the coverage that's provided in different areas, there's often spoken of providing edge or edge compute or multi-access edge computing. All this refers to the same thing, and that's essentially moving computer GPU and memory closer to your end users so that they get even lower latency than just the network provides on its own. So that's taking compute and compute and memory and putting that into our infrastructure, our switching centers, which are closer to end users, and also even on their premises if needed. I will hit the pause button there real quick. Kajin, I may have heard a question, or did anyone have anything they'd like me to touch on more deeply at this moment that I didn't explain well thus far?
Anyone has a question? I think we can go ahead right now. Yeah.
Okay, cool. So those are the things we're going to talk about. Low band through high band. And in Verizon terms, that's nationwide, our ultra wideband, and then the edge that we provide on top of that. Okay. So a little bit more background on networking before we dive into use cases. So how do we actually roll this network out? As with previous generations, there is fiber, right? When you use a cell phone, you connect through cellular radio waves to a tower. But everything beyond that is actually still a wired connection. All of our towers have wired connections themselves, or they connect by cellular to another tower, which has a wired connection. So fiber is still a very huge part of our network, and we are investing a significant amount of capital in that each year, in addition to putting up new towers and putting new antennas and radios on towers for 5G. Small cells is something that's new with the 5G generation of networking. Previously, I'm sure everyone has seen large towers out in front of their house, right, that our cell phones connect to. They're typically extremely tall and definitely would jut out in an environment. It would be hard to miss them, right? Small cells are what come along with 5G. Because they don't travel as far, we have to put more cellular radios out there in the environment, but they can be much smaller, so they're not as obtrusive. We can put these on light poles, for example, or other type of poles that are available, or even on top of buildings and things like that. But we need more of them. So those are what we call small cells. And both the large towers and the small cells are necessary for 5G because we're doing both the low band, I shouldn't say both, all the way from low band up through the high band, okay? A carrier, Verizon, AT&T, T-Mobile, and other carriers, right? They also need spectrum, which is purchased licensing that the FCC makes available to different carriers, where they will use a certain part of the spectrum to provide their specific service. So Verizon has a specific part of spectrum, T-Mobile does, and AT&T does. And that's not just to say it's the same across the entire nation. Verizon has certain spectrum in certain areas, as does T-Mobile and does AT&T and other carriers, right? But those are the big three that folks often think of. So it's about having infrastructure, fiber, and your towers, small cells or large cells, and also spectrum in certain areas to broadcast signal over them and provide service to customers. And then also we have edge computing, like I mentioned. Verizon has this, T-Mobile does this, AT&T do this. We put that compute and memory, or I should say CPU and memory in our switching stations, which are the things that are closest to end users when they go to use their cell phone and their cellular signal connects with a tower and then it goes through fiber into the ground to connect to a core network. The first thing it's going to hit is a switching station. So that's putting that compute as close as possible as end users. I will again hit the pause button there. Any questions on anything I said thus far? Anything I didn't explain well? No? Okay. So just to think about how the model has kind of evolved over time. So here you're going to see on the cloud, on the slide, it says cloud compute in our diagrams, but you could think of this as a traditional data center as well, right? So it can either be a cloud data center or the data center that you used to run out of your basement if you're an organization. So the way that we used to have smart city components or Internet of Things components connect to our data centers where the actual applications are run used to be going through an access network to the data center itself. Now, if the data center is far from you, that means you have more latency. If it's closer to you, that means you have less, okay? What we are trying to do with this edge computing that I spoke about is move some of that compute closer to these devices still. So if they are connecting with a data center that's in California and they are in Spokane, Washington, right? We could move some of that compute closer to them in their switching center that's near Spokane so that they can get lower latency by connecting first with that edge compute that we had before having to go all the way back to that data center in California. So that's how we have moved the edge computing closer to them so that they can get even lower latency for certain applications that they use. I'll again hit the pause button there. Before I go into use cases, anything I have not explained thus far about what 5G is and how we enable it.
I have a quick question.
Sure.
So we are transitioning from 3G to 4G and 4G to 5G. So how are we actually using the previous infrastructure or tools? Are we like replacing the whole or like utilizing the existing ones?
Yeah, very good question. Is it Sung?
It's Seungjun, but you can call me Jun.
Thank you, June. Yes. So 3G actually did get shut down completely this year. Verizon was actually the last major carrier to shut down its 3G network, and we did that in Q1 of this year. AT&T and T-Mobile had done so previously. And 4G is still very much active, right? We use both fourth generation or what's called long-term evolution, LTE, and 5G together. So on our tall towers that are outside that everyone can see, those ones that we talked about having low band on before with the ability to travel far, we still have 4G active on those as well as 5G nationwide. And we will put mid-band spectrum radios on those as well, which we call the C-band or refer to as C-band. And as we develop and enable small cells, that's where we'll make available the ultra wideband. So on the small cells, that will just be the ultra wideband, but we will still have 4G, the previous generation, available on our tall towers along with 5G nationwide for an extended period of time. I don't know exactly when that will be retired. There's no plans to do it just yet. We actually just retired, like I said, the third generation. So 4G is alive and well, and they're both provided on those tall towers and with the same infrastructure, and will be as far as I know, until some agreement is made between standard setting bodies about when those should be shut down. Am I answering your question well?
Yes, thank you.
Sure. Any others before we go on? No? Okay. So let's talk about use cases, and I'll talk about a few different ones. And again, these are from the perspective primarily of first responders and frontline workers in the public sector. Okay, so we can do a lot of cool things with 5G in terms of enabling smart cities, smart campuses, smart airports, smart ports, all that good stuff. But we'll talk primarily about the first responders and public sector folks. So one of the very important things that's enabled by Smart City, the Smart City Foundation that is 5G, is being able to use intelligent video. So video has a significant need for increased bandwidth, increased throughput, right? And also, if we want to use intelligent video to help decision makers make decisions in real time, we also need an ability to have extremely low latency so that we can have analytics run on servers that are not on site or cameras that are on site. Okay, so you'll notice a lot of intelligent video discussion throughout these use cases, but the first one is at intersections. One of the challenges we have as a country, right, and the entire world, right, is pollution, and as well as congestion, which is just inconvenient for folks and is productivity sapping. So one of the things that we can do with intelligent video is post cameras on intersections throughout cities, on interstate highways that travel through them or around them, to make sure that we have up-to-date information on where there is congestion, and then we can potentially mitigate it by, for example, changing traffic patterns or changing light timings, all of that good stuff. So intelligent video is a good way we could do that. Also talking about vehicles, vehicle-to-vehicle communications, vehicle-to-infrastructure communications, vehicle to even pedestrian communications. If the pedestrian has a cell phone, could be useful for reducing potential conflicts between vehicles where they would potentially run into each other, infrastructure where they could potentially run into it, or civilians, pedestrians, where they could potentially run into them. So safety will be something that is also enabled by, or in the smart city, by 5G. And I think you can all probably imagine, which is just totally connect the dots, right? If we're talking about a vehicle, talking to another vehicle or a piece of infrastructure or a civilian and not running into it, we need incredibly low latency for that as well, right? We don't want the communications to be 2 milliseconds too late and then for that reason cause a collision. Situational awareness is another thing we can provide, primarily to our first responders, right? Intelligent video can keep track of what is going on in different areas where we have cameras and be able to alert public safety departments to potentially dangerous situations or other things they might like to respond to, for example, fires, as quickly as possible with the most real-time analysis they can have in centralized monitoring facilities to communicate the right information and give the right direction to folks in the field, firefighters, first responders, paramedics, and also and police officers. Also, not only is capturing that information about traffic flows and real-time situational awareness good for making real-time decisions, but moving that data, again, large bandwidth requirements, moving that data to central databases so we can analyze it later and provide that to people who do infrastructure planning, and land use planning can be appropriate. We can also monitor property and assets without having to invest the time to necessarily go out and see them. For example, at a port, which is often managed by a public sector entity, you could inspect cranes after a hurricane with a drone without having to send someone up on a tall tower. Same things with electrical infrastructure, other things like that. Any place that you have infrastructure that's hard to monitor or costly to monitor because you have to send folks out to remote areas, potentially you can do that with drones or other intelligent video to keep track of that. And then finally, just being able to have 24/7 data and analytics for any other variety of use cases that could be used in a smart city. And we'll talk about a few of those, is an area where we're enabling new smart city functions. Let me hit the pause button there again real quick. Anything I didn't explain well with those use cases before we kind of look at some visually to see how that would be enabled? No? Okay. So we talked previously about vehicle-to-vehicle, vehicle-to-infrastructure, and vehicle-to-pedestrian communications. When I talk about vehicle-to-infrastructure, we're likely talking about traffic signals, right? The thing that controls how our traffic flows, or potentially on an interstate highway to lanes that are open and closed. I know those are not as prominent. So vehicles can talk to each other. They could talk to those traffic signals. They could talk to pedestrians, mobile devices, and that would all be enabled by, again, the 5G coverage and also MAC processing to keep that latency incredibly low. Multi-access Edge Compute processing to keep that latency incredibly low. Now, the ultimate applications for those, the video analytics may live largely in a data center somewhere, but if we can move at least some of that processing to the edge compute, that can be extremely helpful. And this could, again, promote better use of vehicles, more efficient moving of people to the places they need to get, whether that's for leisure or for work, and also to be able to reduce pollution and things like that. And a very related use case, right, is talking about pedestrian and other vehicle safety. So again, same cameras could be put in the same places or on vehicles themselves to make sure that we do not have collisions between people, infrastructure, and vehicles. I'll hit the pause button again there real quick. Am I explaining all that well? Anything that I didn't explain well on the vehicle use case? Okay. Smart buildings is another area we can use it. Again, one of the things that's enabled by 5G is a massive amount of sensors to be placed in certain areas. So if you're putting them outside in intersections all throughout your cities, for example, on lighting, if you want to do intelligent lighting as well, and putting them in buildings, you have to have 5G in order to have all these sensors enabled in one small area. You can put sensors throughout your buildings to do things as ranging from intelligent video for situational awareness for security staff as well, or even public safety staff, to monitoring traffic flows within buildings, to optimize efficiency, their efficient use of them, to keeping track of processes that are taking place in buildings, being performed by people, right? To make sure that they're being performed consistently or that they're being performed according to standard operating procedures, all that good stuff. And then finally, putting sensors throughout your building for example, environmental controls, keeping track of heat, coolness, dampness, dryness, that sort of thing, to give your HVAC, your heating, ventilation, and air conditioning systems the information they need to run as efficiently as possible, and hopefully, again, reduce energy consumption in buildings and, for that reason, pollution. I'll hit the pause button again there real quick. Anything I didn't explain well with the smart buildings use case? No? Okay. And then let's start talking a little bit about what's outside. So in many cases, utilities are run by actual private sector organizations, but in some cases, they are still run by public sector organizations, electrical in particular. Water and sewer are more frequently now run by public sector organizations, but being able to keep track of how they are functioning, have self-healing capabilities, and also being able to inspect them, again, in remote places with things that don't require sending a person out in a vehicle to do a check could be helpful, especially for, again, keeping efficiency up, keeping availability up, and also reducing pollution and things like that. So with drones, we can use to inspect far-flung infrastructure, and for intelligent video or sensors, we can use to inspect stuff that we want to have a more constant eye on. Again, it'd be the connectivity or the information about the infrastructure would be traveling to a tower, which would travel to our MEC, or Mutli-access Edge Compute, and then could inform things like databases, which actually would be probably further away in data centers to keep track of potential challenges that technicians may need to address in the future and schedule preventative maintenance. I'll hit the pause button here one more time real quick. Anything I didn't explain well on this use case that would be helpful for me to go into?
Right, I have a quick question.
Sure.
So you are talking about some various use cases of how government can use the 5G technologies, and
Yes.
I'm a climate resilience researcher, so I wonder how 5G technologies can be prepared for some extreme climate events. So yeah, the extreme events is increasing. So public sectors might be the one that should be operating without any issues. Especially the city infrastructure is the one that should be operating well in that situation. So I wonder if there is any challenges regarding that, and is there any strategies to prepare for maintaining the infrastructure in that emergency situation?
Absolutely. I think what I call the public works use case is a great one. In fact, I should have put this in here, I apologize. So Public Works can put sensors on everything that they're using, whether it's stormwater management, or all the way through to, you know, keeping track of the integrity of dams and things like that. If we're talking about, you know, coastal areas or areas along rivers. So keeping track of the current integrity of your infrastructure, very much like we were talking about here, it can be helpful. And then in addition, sensors to actually monitor the weather is huge, right? So the National Oceanic and Atmospheric Administration keeps track of a massive amount of data from a massive amount of sensors to be able to predict the weather. So 5G will better enable that well. We can deploy more sensors to keep track of more weather indicating data and be able to process that more quickly and get predictive alerts to folks, for example, who might get impacted by a tornado that suddenly emerges. So that's a great example to bring up as well. Am I answering your question, or am I not hitting it exactly?
Yeah.
Cool.
That's great.
Good one. Others? Okay. The very last one I'll talk about, and then give you all some time to ask other questions if you like, is airports. So many airports are actually operated by public sector or quasi-public sector entities. And in airports, they have two significant challenges that we could help with smart airport technologies. The first one is, if you've ever been to an airport recently, a lot of them do fly on time, which is awesome. And that's getting better over time, but we still do have a challenge with delays that impact folks. So the more information we can have about an airplane, when it's landing, how it's progressing from the place it lands to the gate and then gets deployed again, the more we can potentially reduce even further the amount of delays that we have, which again can reduce the amount of pollution we're putting into the air, the efficiency which we're delivering people to their destinations, all that good stuff. So although we have made great strides in flight delays, we could still do better by having absolute real-time, lowest latency possible data to share with the folks who care for these airplanes and get them back in the air. And finally, we still have a number of accidents, minor accidents for the most part, thankfully, at airports where airplanes collide with, or at least come dangerously close to the equipment that's used to service them. So the more exact location information that we can provide about where an airplane is and the equipment that's going to be used to service it, for example, refuel it, hopefully we can avoid having any sort of collisions more in the future. Those two are significant use cases for airports. So again, the sensors themselves, the intelligent video themselves, other communications themselves would be sent through our network to our edge compute with the lowest latency possible, and then information could be kept about it in enterprise systems, data centers, cloud data centers, wherever, for later analysis as well. I'll hit the pause button there again real quick. Anything I didn't explain well about how this could help with airport ground operations? That was everything I was hoping to cover, but I wanted to give plenty of time for questions. I think you said try and hit 30 minutes, Kajin, so I did that. I hope pretty well, but if there's more questions, I'm happy to stay and answer them, or certainly available for questions after the presentation as well.
Right. Thank you so much, Brad. It was a fascinating talk. So I'll just wait to see if there is any other questions from the audience.
Thanks for the impressive presentation, Brad. And so actually I was waiting for the final question because I do have a comprehensive questions to you saying that. So I'm still a little bit confused about. I understand your companies have already achieved a lot of good achievement about using the 5G technologies in helping the smart cities. And as a smart city researchers, I really appreciate that. And since I have got a lot of data from the kind of like the infrastructures and also the sensors, so it's a good one. But when I was working on the project, I do face I think ready just leave. Maybe my question is too long. So I can send him an email.
Yeah, maybe we can wait 1 minute. Yeah, we jump into again.
Oh, no worries.
Good morning, everyone.
Good
Hi.
morning. How's your spring break?
I think we can stop the recording.
Okay. All right. Yeah, I think Brad has some technical issues now, so maybe if you have an additional questions, then yeah, please feel free to send us an email. Then we are happy to connect you with Brad later. All right, so thank you everyone and Brad for a wonderful talk today and joining the talk. And we will post the Brad's video on our website soon. And if you are interested in our future talk, then yeah, we are very welcome to visit. You are very welcome to visit our website at smart.tech.utexas.edu to see our past recordings and any other information for the future talks. So thank you everyone for joining the talk. And yeah, I hope you have a wonderful weekend and the rest of the spring break. Bye.
You.
Yeah, thank you.